Hi, this is Group 7 and welcome to our video presentation on Project 1, which is IMDb Database Design. In this project, we constructed a database modeled after IMDb. During its development, we carefully analyzed the structure and functionality of IMDb's database, giving special consideration to the essential features it offers to users. We began the project by setting up a Discord server for discussions and information gathering. Once that was ready, we used the provided resources to start working on our ER diagram. We didn't follow a fixed meeting schedule. Instead, we worked remotely, collaborating based on individual availability. We tackled different parts of the project one at a time, making revisions as needed and engaging in active discussions to determine our next steps. Okay, let's start by discussing the initial entity we focused on, which is the media entity. The media entity serves as the core and central entity in this database. It has a relationship with pretty much every other entity, and we'll talk about those relationships later on in the presentation. It's important to note that this entity includes a wide range of media types beyond just movies. It includes TV shows, trailers, and more, essentially covering any form of media found on IMDb. In terms of attributes, it has quite a bit of them, with Media ID being a key attribute. It is used to identify media, let's say movies, with similar or identical names and identical release dates. This is how the actual diagram of the media entity and its attributes looks like. It consists of the key attribute media ID that we've just mentioned. Few multi-valued attributes such as genre, because a movie could have several different genres like action comedy or horror drama, adventure thriller, and etc. And same goes for stars, because a movie could have many roles and actors, many awards, and even different production companies. For example, Spider-Man No Way Home, which was produced by both Sony and Marvel. The entity also has a couple of derived attributes, like rating score and total ratings. Their values are calculated using other pre-existing attributes, and we will discuss on how they work later in the functional requirements section. Next entity is the episode entity. Every media entity may have multiple parts in relation to the episodes entity, and every episode entity must come from a media entity with multiple parts. As you can see on this diagram, it is a weak entity because without the original media, like a TV show, the name of the episodes of that TV show and episodes themselves wouldn't really exist. So that's why it's a weak entity. It consists of attributes such as episode ID, which is a key attribute for this entity and serves the same purpose as the media ID that we already talked about, like identifying the exact episode. However, it also has the number of seasons and the number of episodes included. Couple of derived attributes, same thing as the media entity, and some regular attributes such as air date, episode name, synopsis, and stuff like that.
Alrighty, so moving on to the database requirements for the review entity. This is going to be a weak entity which relies on the existence of a particular media. In other words, a review cannot exist for something that doesn't exist. So someone can't give a review to Ahsoka before Ahsoka was a show. For the actual relationship between this and the media entity, every media can have multiple reviews, but every review must have a related media entity. One of my peers will go over the more specific constraints within the relationship. But moving on to the attributes, this is going to have a primary key of unique user ID. That's how we're going to distinguish in the database when a user has posted a review to this particular kind of media. Then we have the date posted, reviewer username, review text, review title, and review score. This is mostly important in the database for displaying the information. So when you go to that website, you go to the site, you go to this particular episode, you go to the reviews, and you say, okay, this user said this. well, now we know how to display it and how to format it. Moving on, here is the actual diagram we have. This is the that weak entity review. It has that double constraint of the total participation to the identifying relationship. And then again, the primary key user ID, and then the rest are going to be all regular attributes, all in relation to the media entity. Moving on to the writer, director, and actor entities, these are all going to share essentially the same set of attributes and the same constraint when relating to the relationship towards the media entity. For the actual attributes of all three of these, we're going to have the primary key, unique ID. This is that unique ID that's assigned to different people. So Edgar Wright has a unique ID. So whether he is an actor, a director, a writer on particular things, this is how we reference him and his credits. His name is going to be a composite attribute. It's going to have first name and last name. This is good for querying. And then, of course, we have the birth date, height, and resume, all regular attributes. We also have the awards won and official site attributes, but these are multi-value attributes due to the fact that someone could have multiple awards and, of course, multiple websites, whether that's a Twitter, Facebook, MySpace, if they still have it. And here is the actual diagram for this, where we have, again, those two multi-valued attributes, the one composite, our primary key, and then the rest are all regular attributes. Here are the functional requirements, or part of the functional requirements. So first and foremost, we have the average rating score. When you go to a show or a movie and it says this movie has a 3.8 out of 5, well, how does it get that? This is how it gets it in the system, where we take the mean average, or we take the sum of the values, we divide it by the number of values, that gets our mean average. I'll get into how we get our number of values here in a second, but for the actual sum of the values, it takes all of the review scores relating to that media entity, and it takes it and adds it up, gets the sum, divides it by the number of values, which is our next part of the functional requirement, which is the total ratings. This is the denominator in that calculation I just showed you. It's going to be calculated as an incremental total, and it's going to pertain to the total number of ratings reviews. So it might say, this show has 6,000 reviews, and that gives us further context to the ratings, as well as the user context to what they're looking at.
Here we have database relationship types, which are schema descriptions that identify constraints in a relationship between entities. They do this using the cardinality ratio. This consists of 1 to 1, 1 to many, many to 1, and many to many. On an ER diagram, these are depicted using the number 1, the letter N, or a letter M, in the case of many to many. There are also participation constraints, which consist of total or partial. These identify whether one side of the relationship can have 0 participants, or if they must have at least 1, and are depicted with a double or single line respectively going from the entity to the relationship. In our diagram, we have 6 entities with 5 relationships between them. All of the relationships in our database pertain to media in some way or another, making it an important entity to our database. The first 2 entities relating to media are episode and review. These are weak entities due to them requiring a particular media entry to relate to them for them to be considered distinct. Both have a total relationship with media due to this. They also can only relate to one media entry. Media, however, has a partial relationship with both episode and review, allowing it to have no episodes or no reviews. This is due to movies falling under the media entity and reviews coming under the media entity when it is created and are submitted by users or critics. The last 3 relationships are also similar to each other. These pertain to actor, director, writer, and how they relate to media. These are regular entities contrary to review and episode. They do not require a particular media entry to relate to in order to become distinct. Both sides of this relationship have a total participation constraint. This means that an actor must have at least one media they are relating to, and media must have at least one actor it relates to. This can, of course, have more than one, even when the same relationship applies to directors and writers, allowing media to have multiple directors and writers. The main difference in this relationship with media that actors, directors, and writers and entities have is how they relate to the media entity. This, of course, being that actors have roles in the media, directors direct the media, and writers write it. Here we have an example of the relationships we just talked about with actor and media. You can see by the double lines we have a total participation constraint on both sides of the relationship. You can also see the N and M on either side of the triangle that depict the cardinality ratio for the relationship type. You can also read what the snippet depicts above and below it from actor to media and from media to actor. Here we have the full ER diagram of our database. You can see all the elements we have discussed during our presentation. You can also see how the media entity is almost centered with every other entity relating to it. You can see how the weak entities, episode and review, are at the bottom. Actor, director, and writer are the remaining entities going along the left side and up to the right. You can notice the various attributes we discussed previously attached to their respective entities, and while it may seem like a lot, hopefully this presentation helped you to understand our diagram better. And that is everything about our database and proposal for it. There's also a report going into more detail that is provided. If you have any questions, please don't hesitate to ask. Thank you for your time and have a great day.